Hi, this is Jared from class 257, and this is a guide to the Scale and Load Balance Your Architecture lab. Um, some background to the concepts we're going to be doing in this lab are elastic load balancing and autoscaling. And elastic load balancing basically is a process that automatically distributes traffic across multiple services or systems and instances, so no single instance or system gets overloaded. It, like they say, is to achieve fault tolerance. Um, so the basically, it's in its name, the load of traffic gets balanced across multiple systems. And then autoscaling is basically, instead of just provisioning a set amount of capacity for your system or instances, you can provision or instances are provisioned and um, created as traffic increases or decreases. And the slides this week actually have a really good graphic on this, where instead of either over provisioning, where you have a bunch of unused space, or under provisioning, where you potentially go over capacity and may cause your systems to shut down, you can instead just have provisioning as or auto scaling as capacity comes in demand or out of demand. So those are the kind of some background topics for this lab. Here's kind of graphics of the infrastructure we're working with in this lab. This is the infrastructure we're starting with, and then our infrastructure by the end of the lab will look something like this. So this is where we actually start the lab and open the console, but I went ahead and already did this. And then the first step is to go to EC2 and see our instances. We are asked to create an AMI from existing web server 1, so we're basically saving the contents of the web server 1 so new instances can be launched. So I'm already here, but we can just go to EC2 right away. And then this is what will pop up, and you'll see the two instances. And you'll see web server 1, and its status check is 2 out of 2, which it says to do. We need to basically make sure it's up and running for us to create a copy of it for our autoscaling. From select web server 1, in actions, click image and template and create image. Actions, image and templates, create image. Image name, web server AMI, and then lab AMI for web server for image description. Web server AMI, and then lab AMI for web server. And then create image. And then we will get a confirmation banner that displays the AMI ID. So scroll down, go to create image. Our image is created and we have our ID right there. Next task, create a load balancer. Now this task, there are a few steps that can be a little tricky, so just try to keep with me because it says to like click next and whatnot, but instead it's a different layout than what it is describing. So you'll see what I mean when we get there. Navigation pane on the left side and go to load balancers. Okay. Create load balancers, and it will note that there are several different types of load balancers displayed, and we are using application load balancer. So under Application Load Balancer, click Create. Create. Here's the multiple different ones. Under Application Load Balancer, which is this leftmost one, click Create. Its name is Lab ELB, and we are using the Lab VPC. Lab ELB, and we are using the Lab VPC, which we just scrolled down in Network Map. Under Mappings, we want public subnet 1 and public subnet 2. Click both availability zones and then click public subnet 1 and public subnet 2. So both availability zones. And it already has both subnets we want, public 1 and public 2. But if it was on private, you can just click the drop-down menu and go back to public. Scroll down. Now, it says to click next to configure security settings and configure security groups, but we just scroll down and we're already at the security groups section. So what we need to do is select web security group and deselect the default security group. So deselect default and then click web security group, which is our first option. Now, after this, configure routing, which we just scroll down to listeners and routing. And routing configures where to send the requests that are sent to the load balancer. We will create a target group that will be used by autoscaling. So in this case, we have to create the target group, and then this new window will pop up. And we don't have to do anything in here. All we have to do is type the name, which is lab group. And then we scroll all the way down and hit next. And then, since we don't have this next, click next register targets, we have to note that autoscaling will automatically register instances as targets later in the lab, so we do not need to set any targets in this new page. So we just scroll down and then click Create Target Group. Now that the target group has been made, we can just close this tab. And then nothing's there, so we just refresh with this little button, and then the lab group should be there under the listeners and routing. So that is steps 17 through 19, basically. Next, we go to review, which we just scroll down, and it's the summary. And then we create our balancer. And then we can view our load balancer. And this is it. Next thing we will do is create launch configuration and an auto-scaling group. So in the left navigation pane, we go down to launch configurations and then click create launch configuration. Launch configuration is down under auto-scaling, and then create launch configuration. Its name is going to be lab config, and it is the web server AMI. Lab config. Don't know if the space or not matters. And then web server AMI, which will load web server AMI. For instance type, choose T3 micro, or choose instance type T3 micro, and then choose. But you do have to note that if we are in US East 1 region, we need to select T2 micro instance type instead. So to check our region, we go up in the top right corner, and we are in North Virginia, US East 1. So in this case, we will use the T2 micro instance type instead of the T3. So instance type, choose instance type, T2, the T2 micro. And then under additional configuration, select enable EC2 instance detailed monitoring within CloudWatch. So scroll down to monitoring and enable EC2 instance detailed monitoring within CloudWatch. And then we scroll down to key pair, security group. And then we select an existing security group, and then we select web security group with the checkbox. Now under key pair, choose an existing key pair and type in existing key pair Vaki. So choose an existing key pair Vaki, and then we have to click the acknowledge. And then we launch our configuration. Our configuration has been made. And then with this configuration, we now need to make it the auto-scaling group. So we select it and then go under Actions and Create Auto-Scaling Group. So select it, Actions, Create Auto-Scaling Group. It will be called Lab Auto-Scaling Group, and then we will click Next. Auto-Scaling Group. And then we can go ahead and click Next. And under Network, we want the Lab VPC and Private Subnet 1 and Private Subnet 2 when it comes to the options. Lab VPC, and then for subnets, Private Subnet 1 and Private Subnet 2. And then we can go ahead and click Next. For load balancing, we choose attach an existing load balancer, and then this little pop-up comes up, and then we choose from your load balancer's target group. And then in the drop-down list, we select lab group, which we created earlier in this lab. In additional settings, select Enable Group Metrics Collection within CloudWatch, which is just down at the bottom here, and then click Next. Now we have to do our desired capacity and our minimum capacity. So desired 2, minimum capacity 2, maximum capacity 6. 2, 2, 6. Oops, 6. Now under scaling policies, choose target tracking scaling policy and configure. Now, its name will be lab scaling policy, and its metric will be average CPU utilization. So, lab scaling policy. And average CPU utilization, which is already selected. And our target value will be 60. This is basically listing, I believe it says, so our average CPU utilization across all instances will be 60%. The auto-scaling will automatically add or remove capacity to keep the metric as close to that specific value as possible. and then we choose next, and we don't want any notifications, so we choose next. And we do want a tag with the key name and the value lab instance. So tag name lab instance. Next. Review the details of your autoscaling group and then create autoscaling group. So we have our subnets, we have our load balancer, and our target group is correct. We have our desired minimum and maximum capacities correct, and we have our no notifications and a key, or a tag. Create autoscaling group. We see that it is starting to make, and it also says here that it will initially start with a count to 0, but we can just refresh it and we'll see our desired count of 2 will pop up. So it says 0 and now refresh, and 2 instances, which is our desired count, pops up. Our next task is to verify that load balancing does work. So in the navigation pane, we go up to instances, and we should see 2 different instances from what was there before. So instances on the left-hand side. We had our original 2, and then 2 more instances are there, which are our desired instances. And we can see they are still initializing. In the left navigation pane, we then click target groups, which is right under where load balancing was. Target groups. And we see our lab group that we created earlier. We choose the lab group, so click on the blue name. And then click the target tabs, and we'll see 2 instances instance targets that should be listed for this target group. So targets, and we see our 2 instances, and they are both healthy. We need to make sure that both of them are healthy. If not, just wait there and refresh the page every once in a while. As they say, healthy indicates that the instance has passed the load balancer's health check. And that means the load balancer will send traffic to those instances. Now go to the navigation pane and click Load Balancers. Load Balancers right above target groups. And then in the lower pane, copy the DNS name of the load balancer and be sure to omit the A record part. Should look similar to this. Just so you know, sometimes when I first did this lab, this pane was way down here, so you can just click right here and drag it up to be able to see it all. And then we can see our DNS name. You can just go ahead and select that and copy it, or you can just click the little icon and it'll say copied. Now open a new web browser and paste what we just copied. So new web browser, paste. Now we are able to see this window. We'll see our availability zone and the different instance IDs, and our current CPU load. Now, one thing that is actually kind of interesting is if you keep refreshing this window, you'll be able to see the availability zone will change. So that's showing that the load balancer is sending you to different availability zones, like that image at the beginning of the lab showed our infrastructure. So it went from 1A to 1B and 1B to 1A. It's just something interesting that I found to show it works. Now in the next test, we are testing our autoscaling. We created a minimum of 2 instances and a maximum of 6, and currently 2 are running because that is our desired, and also our minimum. So we have this window open, but do not close it. we will instead go back to the console and go to CloudWatch. Go to CloudWatch, which is under Management and Governance. And then we can just close that. It's a notification. And then in the left navigation pane, click Alarms, which we have alarms. This is just a drop-down menu, so you can just click all alarms to see all of them. And then we can see the two different alarms we have. Two alarms will be displayed, and these were created automatically by the auto-scaling group. They will automatically keep the average CPU load close to 60% while also staying within the limitation of having 2 to 6 instances. Also, it does note that if you don't see these alarms within 60 seconds, that means there's been a step that wasn't done correctly, so you have to follow these steps to fix that. If you've been following along with me, we do not have this issue, so we can go ahead and continue. Click OK. Click the OK alarm, which has alarm high in its name. If no alarm has OK in its name, we can just refresh until status is changed. So we'll go ahead and click on it. And here we're able to see the CloudWatch graph and see how the CPU is doing, or how its utilization and how heavy it's running, basically. Return to the browser tab with the web application. Oh, also I forgot to mention that the alarm high is, it says OK when the alarm is not going off. So right now it is OK because the CPU utilization is less than 60%, which is that value we inputted earlier. So click the browser tab and then click Load Test, which is beside the AWS logo. So this tab and then Load Test. This basically, I think it is a stress test, so it is just putting maximum load through our instances, and it auto refreshes to keep updating. Generate high loads, the browser page will automatically refresh. We do not close this tab. Return to the CloudWatch console, and we can see all of our alarms. And go ahead and refresh this. This might take a few minutes for the step to continue, but basically we're going to be sitting on this page and refreshing every once in a while until this alarm high changes to alarm. It may take a few minutes, but it says it'll take less than 5 minutes, basically. So we will return then. Okay, we are back. It's been a few minutes, and the alarm high is now in alarm, according to our plan. I should have also stated that once the CPU percentage crosses the 60% line for more than 3 minutes, it will trigger the auto-scaling to add instances. So the alarm is going off, and now auto-scaling is attempting to add instances as much as it can to basically prevent overloading. So we can also then click on this and see that our CPU percentage is in fact peaking right now at 92%. So the alarm high is in the alarm state. We can now see the additional instances that have been launched. So we can go to Services, EC2. Now we should see more than we have to go up to our Instances tab. We are still on the Lab Groups tab. We now see more than just the 2 instances and the 2 desired instances. There's now 4 here. So, and we can see they're still initializing. So our auto-scaling does in fact work. And now that we have our auto-scaling made, we can go ahead and terminate Web Server 1, which we only use to create the AMI for the auto-scaling. So select Web Server 1, go to Instance State, and then do Terminate Instance. I also want to state that if you were to sit here for a few minutes, you would be able to eventually see all 6 lab instances up and running, but we only just need to see the 4 to prove to us that auto-scaling does in fact work. And that is the end of the lab. I hope I was clear, and I hope I was able to provide some clarity to some of the steps that may be more confusing. But until then, that is the end, and I'll see you next time.